Thanks everyone for joining. Welcome to a new episode of Datadog On. So Datadog On is a series of webinars that we do where we invite engineers who are working on a daily basis on building Datadog itself to talk about a technology they use, a process they follow, or a product they're building. And today we are going to be talking about game days, what they are, how we organize them, and how we run them here at Datadog. Any previous episodes and register for new ones and the recording of this one as well, you can see on our website, datadogon.datadoghq.com. So you can see any other previous episode if you're interested there. So a couple of things. So in case you don't know what we do, Datadog is a monitoring analytics platform that helps companies improve observability of their infrastructure and applications. Also some housekeeping items. We are going to leave enough time at the very end. We like these sessions to be as interactive as possible. So we leave about 15 minutes at the end for questions. So if you have questions throughout the session, don't wait until the very end. You can use the Q&A button in your Zoom client. You leave the question there, and at the end of the session, we will try to address as many as we can. My name is Ara Pulido, by the way. I'm a technical evangelist here at Datadog. I'm one of the co-organizers of these events. So if you have any feedback or you want to suggest a topic that you want us to cover, please reach out. I'm always happy to read and answer your questions. But the important people today to talk about game days are Elijah and Mike. Elijah, do you want to introduce yourself?
Sure. Hi, everyone. My name is Elijah Andrews. I'm a software engineer here at Datadog. I work on infrastructure. Right now, I'm on the traffic team, and we're working on the application network layer for like internal Datadog services at the company.
Yeah, hi, Mike Petruzelli. I'm an SRE here at Datadog, and I'm on the core resilience team, and we handle major incident response and remediation processes and the large-scale game days at Datadog. So kind of our failures kind of wrapped up into one team, both reactive and proactive.
Before we start with game days, we always like to talk a little bit about the scale that we run on, because some of the decisions that we've made while building Datadog are related to the scale. So some of the things will be perfectly applicable to your organization. Some of them depend on other things, but just so you know, we have more than 12,000 customers. We are a monitoring company, so we gather information from those companies. Those add up to millions of them, and that translates into trillions of data points per day that we need to process. So that's more or less what Datadog is internally. But today we are going to be talking about game days. Before we dive in, Mike and Elijah, give us a little bit of two-sentence, your view of what a game day is.
Yeah, I think I would say that a game day is proactively putting your systems through adverse or turbulent conditions, but in a safe, controlled environment so that you can learn and observe, from those live effects.
Yeah, and really what we're trying to do here is induce like a specific failure into the system, and then observe what happens, right? So this is like a database goes down, or you receive like a huge amount of traffic that you're not expecting, or your network is partitioned or something like that. You're really just sort of like making a hypothesis about what is going to break. You make that thing happen, and then you see if your expectations were correct.
Yes, and Laia, during this preparation, you've talked a lot about thinking about this as a form of testing. Can you expand a little bit more on that?
Yeah, I mean, I really think game days are just sort of about validating expectations and like testing sort of systems that you've written. And it's not unlike any of the other testing that you do when you're like building a software system, right? So if you're building a new application, you start off like, you write a bit of code, and then you write some unit tests on like a function that you've written to make sure that that thing behaves as expected, right? And it'd be like a pretty bold move to completely forego unit tests and just be like, yeah, like, I don't know, I'm sure my code works properly. I'm sure it's never going to change and I never need to communicate expectations, right? Like, no, you're not going to do that. You're going to write unit tests. And then like, once you have a few components and they're working together, like you're probably going to write some integration tests to make sure that they communicate as expected. And like, you want to be able to like assert that everything is working correctly before you just throw it to the world and have people use it. And then if you're like, you'll probably also do like a little bit of end-to-end testing where like you test important flows in your application or how like large, certain components interact like at a broader scale. And this is just sort of taking that to another level with Gamedays, right? So how do you test like failure in your ecosystem and platform as a whole? There are a lot of sad paths in your code that you probably can't really hit in like a unit test, right? Like what happens if your underlying network behaves unexpectedly, or a dependency that you don't have in your testing, that you've mocked out in your testing, like breaks. And so this is really just sort of trying to take testing to another level and make sure that you're building resilient software systems. Mike actually has like a great sort of analogy to this from some of his past work experience.
Yeah. Early in my career, I built hardware systems for the DoD here in the US. And you have some really interesting questions to ask manufacturers, like, what if I stuff every port in this full of sand, or fly it into space, or drop it off of a plane? And you can ask and you can do small scale testing, but we were required to prove these objectives, these requirements. And a lot of times that meant a fully built rack of servers put into a lab and had a massive weight crashed into it while we're operating the system, validating it continues the entire time. And kind of how we've taken hardware and moved that into the cloud, we need to take that validation testing and move that to the cloud. We take big weights in the cloud and slam them into our infrastructure.
So what would be a more formal definition? Other than that is slamming.
Yeah, we are doing science here. So importantly, a game day is an event, and our aim is to experiment our application's resilience, and slightly different than reliability, but resilience when facing abnormal and turbulent situations. So maybe more simply, you break the system on purpose so that you can learn from what happens, and you do it in a very controlled manner where you plan and warn and have objectives beforehand. And ideally, you move this all the way into production, because testing in any other place is still just making an assumption and not validating an experiment. And those are slightly different things. The nuance does, change your perspective though. And sort of how do we put them together? There's many ways to slice and dice a game day, but we move through this sort of iterative situation of planning our scenarios. So that's from various risk reviews and product launch reviews that we have. We also, like I said, we're responsible for incident management. So we see all the high severity postmortems, and that gives us a good idea of situations that we need to validate. We then, run the game day. We do these experiments, we collect our data, and then really importantly, we analyze that data. The two longest kind of categories here are 1 and 3. The planning takes a really long time, and the analysis and coming up with real actionable items out of that. What are the objectives that we're going to fix now that we've observed this behavior? And kind of, why? Well, your systems are going to break anyway. And having that planned at 9 a.m. is much nicer than having it wake you up at 3 a.m. Or even worse, not having the observability and monitoring in place at 3 a.m. when you need it to wake you up. So we can kind of fast track this by inducing failures and proactively fixing, items that we can induce as problems. A real customer impact really is how we measure it. And why do we need to do this, right? Well, we're all human, and it's something as small as a typo can bring down, say, like S3. If you've been working in the cloud for long enough, you can definitely you've got the battle scars of these situations. And various things are going to happen sort of out of our control no matter what. The world is chaotic, but we need to provide that stable platform really for Datadog, especially like for our customers.
Yeah, people really rely on Datadog to be up when the cloud or when their infrastructure is having issues. So we really need to make sure that our failure modes are not correlated with those of our customers. And so we take game days and reliability and this sort of stuff like very, very seriously. And so we're really trying, you're actually really exercising like a whole bunch of different things when you're running these experiments, right? There's like, so the obvious ones that you're trying to test are like, do your systems fail as expected? Like when you do the thing, when you break the thing, does it break in the way that you think it breaks, or does it break in new and surprising ways? And then like another thing that you're trying to test with this is like, after you fix the problem that you induced, does your system actually bounce back and recover on its own without a human having to go fix it? This bouncing back case is actually like the most interesting part for me. I've been thinking a lot about like stateful applications and sort of like how developers reason about their programs, right? And any program is really a state machine. Like you have memory and you have variables in there, and whether or not you actually model it explicitly as a state machine, like it is one, right? And sort of a common joke in computing is like, have you turned it off and on again, right? And whenever you encounter a problem, it seems that if you just like turn that machine or that device or whatever like off and on again, everything kind of works as expected. And it's kind of magic, but I think the reason that works so well is because what you're doing when you're resetting your application is putting it back into a state that the developer has a very good understanding of, right? When you're writing your application, you write a bit of code and then you run it and you see if it works properly, and you're entering like that clean startup state so many times. You're not often entering the state where your code has been running for 3 months and the network is yanked out from under it, or the disk goes away and then it comes back, and like as a developer, you're like almost never witnessing that state hands-on and actually watching a system when that happens. And so like the bouncing back case I find is where often when we run game days, we fail sort of that scenario because it's just so hard to replicate outside of these actual situations. Anyway, like there's a lot more that we're actually trying to exercise too, though, right? Like you're also trying to exercise the observability and monitoring of your system, right? Like you're probably running these systems at scale. You don't want to be looking at them all the time. And that means that you have dashboards, traces, and logs that you can use to tell what's happening in your system as a whole, either using Datadog or some other platform. It doesn't matter here. And so like, do you have the right observability tools in place to understand what is happening when your system breaks? And as Mike mentioned earlier, like, do you even know it's broken at all when this happens? Or would you just sleep through a problem and have like your boss be really mad at you the next day when you come in and they're like, everything was on fire last night. Where were you? And then like, so getting even further from like the actual applications themselves, like you're also sort of exercising process and sort of like non-technical aspects of the way that your company operates, right? Like, what happens if the person that is an expert on the system that you break is on holidays or sick or leaves the company or something like that? Do you have enough organizational redundancy and understanding to fix this problem when that person isn't there? I think like Mike has a bit to add here.
Yeah, I think, the archetype, say like from the Phoenix project is Brent, the magical person that sits at the machine, whispers magical, the incantations, and suddenly everything's fixed. And you might have several of those people. You might have that at different levels in the organization. But the organization, the product has to survive them moving on, them being on vacation, just being unavailable. And in the large scale game days, this is a real big focus of ours, because we need to spread that knowledge and have it be institutional and not have it be siloed to like any one person.
And this is a thing that we actually do and put explicitly into our game days. Like I've read procedures for game days that we want to run that have steps in them that are like, make sure that this individual person is like not at their computer when we do this. Like actually have them go like out and get coffee or something, because like we really want to see what will happen when they're not there and they're not running their magic incantations to fix the system. And then sort of the last thing that you're really exercising here is communication. Even so, especially with COVID, but even before, like this industry was quite distributed, we often communicate over computers and not in person. And so what happens when your primary means of communication is down, right? You can replace Slack here with like Google Hangouts or Zoom or IRC or whatever communication thing you use, but it's sort of the same principle here. Like what happens when your primary means of communication goes away? Like if Slack is down and you use that during incidents, how do you tell people to move to another thing? Is that a thing that you have a procedure for, or will you just be lost? And really simple incidents can escalate very quickly if like everyone is operating in a silo and trying to fix it independently. So this is like definitely something that you should be exercising when you're running your tests.
The next question would be, what are the goals? Why we're doing this? What is the end game here? Why are we doing all this? That it seems to be seems a little bit scary, like we are going to break the system because we want to do that. So what's the end goal here?
Yeah, I mean, ultimately, we have to. This is a pretty simple, say, example, and this might include many things in your company, billing systems, what if you can't reconcile your books or something like that. But your organization is ever changing, it's ever growing, and our goal is to nurture that. So we'll never be able to find all the sad pathways. We'll never be able to just make assumptions about all of these distributed interactions. So realistically, what's the number one or like the primary reason? For us, it's about resiliency. It's about that idea that we can bounce back from any failure, or no matter what challenge we face, the customer will never see that. We will move that traffic or send that load over somewhere else or something like that. And that's slightly different than reliability. A system can be very reliable because it's never been challenged, and have very, very poor resiliency in the face of its first challenge. So the idea is to constantly be building that sort of defensive muscle against anything the world can sort of throw at you. And we need to do that in a holistic way, because there's people managing these services. And so when things go wrong, like they need to know what to do. So we also do it for training purposes. So we can organize these events and have people go through their run books and move traffic and force them to sort of exercise their own teams, because new people, new processes, the ever-changing landscape, we can force these things to happen. Whereas in the past, we could only react after an incident and say, yes, we should go update these. We had a problem. It held us back. And I think there's that organizational confidence as well.
Yeah, I mean, confidence building, it's sort of related to training in the sense where, like, at sort of every level in your company, you need to make sure that you have confidence in the systems that you've built. So like starting at the lowest level, right? Like the person that wrote a service, like maybe you wrote a service and you expect that it's going to work properly when you induce all these failures, and it could be part of your design. But how will you ever know that it actually does that unless you exercise those paths and see what happens, right? But this goes further than that, right? Like then other people in the company probably want to rely on the systems that you're building. And if they're going to depend on your system, they want to know that you've sort of taken it through, that you've tested it and validated that's going to work properly. So like the people that want to rely on your system will do that too. The managers of the systems that rely on the systems that you're building want to know that like they're not going to hurt their products if they add a dependency on your system. And finally, like you have customers at the end of the day, they're the ones who really want to make sure, like they want to use Datadog and they want to make sure that everything is working properly. And if we can sort of like demonstrate to them and show them that like we've put the system through its paces in adverse conditions, they'll be more confident that we're going to be up when we need them. And then sort of like the final thing, like I think game days are actually super fun to run. Like it's fun to sort of like come up with a big plan and induce like a big issue in your system, and then see if your assumptions are correct. For instance, like I kind of think of game days as like setting up a bunch of dominoes. Like you sort of like create your big plan, which is like laying out all the dominoes, and then you knock them over and you see what happens. And like in incidents, it's never just one thing that goes wrong, right? It's like this system broke and then the system broke, and in isolation, everything is fine, but together it can cascade into this huge issue. But also it's like super satisfying if you set up your dominoes and they all cascade and fall as anticipated. And that doesn't always happen. Sometimes as you're setting them up, they fall and you make a mistake and you knock a bunch down, or sometimes like the experiment doesn't go exactly as planned, but sort of like this controlled chaos is like really satisfying to witness.
I like the analogy. It's very, very good. So what are we aiming for in this? So if we take again that analogy of all the dominoes falling perfectly, that's what are we aiming for here?
Yeah, I mean the desired end state, or like a perfect game day would essentially be almost nothing. So everything we could dream up, every scenario we could come up with, every previous incident we're recreating, we were able to just defend all of it, never recorded an impact. You probably did a lot of scheduling, had a long time period to go through a lot of scenarios, and you kind of run through them very quickly because the observed effects just are instantly kind of failing over. And that's all good. Like that would all be just a perfect thing to have happen, right? You're completely out of ideas. You can do this quick and easy analysis. If there are any remediations, just plan for them and get on to that next game day. Does that happen? Sometimes. I mean, more often, you kind of walk into a bit of a situation and there's cleanup, remediations, and probably that next game day might just be an iteration. So especially at first, and I want to really emphasize that this is a muscle we're going to start building here. So when things go wrong, they tend to go really wrong, and your controlled chaos goes uncontrolled relatively quickly. Our intent is to try and manage that, but depending on how well sort of your mitigations work, those can get out of control. And I kind of think back to things, how we got to space or got to the moon. It started with these massive one-use rockets that took billions and billions of dollars, and through iteration and technology improvements, we can reuse these boosters and things like that now. So, it takes a lot of false starts. Don't get discouraged, because each one of those false starts is you getting better. Like you're going to learn. That's the entire objective. And really in the beginning, you'll probably be sitting on a lot of data and kind of be confused about what to do. And just picking out some short and long-term objectives and getting them just identified moves you along to those next pieces of your game days. And really that's what we're doing, is building that maturity.
Sounds good. So let's start talking about game days at Datadog. So we've talked a lot about why we do these things and what they are. So Elijah, you've been for 5 years at Datadog. So I guess you've seen all of how these things have started. Can you tell us a little bit more?
Yeah, definitely. I mean, I promise these are a thing we actually do. We're not just telling you to break your stuff on purpose. Like that, this is absolutely a thing that we do. And sort of like Mike stated, I do really want to like reiterate that these didn't just sort of happen out of nowhere, right? They evolved gradually, and they got increasingly complicated. But at the start of the day, they were really just starting off with individuals testing their services and seeing if they broke as expected. Like very sort of simple things, right? We would have an incident where one of our databases would go down, and the incident was bad, and we didn't handle it properly. So then after that happened, we wrote some code to try to fix the problem that we had, and wanted to test and make sure that that wasn't going to happen again, because it made us very sad. So these are sort of like things that we started doing organically. And we noticed that the teams that were doing these types of testing on their system ended up with systems that were up way more, and their pager loads were way better, and everyone was way happier. And so it really started sort of becoming part of our culture, where we would go and induce these failures in our system proactively to make sure that they were working as expected. And then we had a few sort of like really big incidents. One of them is like that S3 outage that Mike was talking about earlier, where it was very much like platform components that were failing. And it's hard for individuals to sort of induce like an S3 failure and see how that would work across our entire system. And out of that was sort of born like our SRE organization, how it exists today, where we have specialists who understand sort of how to perform like breaking operations at a large scale, and also who are able to organize these experiments, right? When you're running an experiment across your entire infrastructure, it takes a lot of coordination and a lot of work, and we realize that was sort of like its own job. And that's like the team that Mike works on now. And so really today, like we have two types of game days, right? We have these like small scale game days that are run with very tight iteration cycles. Like you can go from like coming up with the premise of your game day to testing it, to integrating the results like in a few days. And these are things that we run all the time. And then we also have these like really big, large scale game days that take weeks, if not months of planning. It's like dozens, if not hundreds of individuals involved. And so we find that like both of these sort of experiments or both of these types of game days are really useful in helping us design resilient systems. And so I'm actually going to give you like an example, like a concrete example of like a small scale game day that my team actually ran on a new system that we were building. We ran this game day early on in development to build confidence in our system and our design choices. And hopefully this sort of like puts things into concrete terms so you can understand like what we're actually talking about here. So like the problem that my team was trying to solve is that of surface discovery, right? So just to quickly define what I mean when I say this, like basically what you're trying to do is take you probably run software systems that have a bunch of different network dependencies, right? You need to connect to different things over your network, for instance, like databases and things like that. And you need a way to map sort of the notion of that database that a developer understands, right? Like Cassandra in this instance, which is like a column-based data store. You need to map that concept into IP addresses that your computer can understand and actually route packets to, right? Your computer works on IP addresses. And so to perform that mapping, people call this problem service discovery, and usually they build software systems that can do this lookup. And so the system that we designed like does exactly this. It maps like service names to IP addresses, right? The design that we came up with is we have a central database and we put service names in there and then we store IP addresses. We have a registration controller that goes and talks to sort of our runtime and scheduling engine and figures out like what instances of the server of that service are actually running and takes those IP addresses and puts them in the database. And then we have a DNS server that sits in front of that database and answers questions to clients so that they can do that mapping. You know, this is obviously like a simplified view of the system. And there's a lot of context here that's missing. Like I'm sure a lot of people are kind of looking at the DNS-based service discovery approach and maybe wincing. DNS has a lot of issues and is quite special, but trust me, like in this case, we used it for a reason that made sense. Basically, it's like quite ubiquitous. And all of our clients already knew how to speak it. So we accepted sort of the pitfalls of using it for service discovery for the system. But you know, this is basically what the real design is. Like today, just for a bit of perspective, today we have the system deployed on dozens of Kubernetes clusters. It supports hundreds of services and tens of thousands of IPs at any given moment. It runs across several cloud providers and it's answering hundreds of thousands of requests per second, so, even though it's like quite a simple design. And so like the one thing that we noted really early on when we were building this is that it's going to be a dependency for pretty much every other application at Datadog. And so from the start, we were really thinking about like how this thing could break and what would happen when it did. And so the first thing that we did actually after we had a rough design was actually build a prototype and start game daying it. So the game day that we actually ran was this. We wanted to figure out what would happen when the database dies. And like keep in mind sort of the fallacies of distributed computing that we were talking about earlier, right? Like this is a thing that is going to happen, whether we like it or not. We can fast track this by actually inducing the failure ourselves. And that's what we decided to do. And so like the key insight that we had when we were coming up with this plan is that like when we encounter problems with the system, we should favor serving stale results over serving nothing at all. And this is pretty reasonable because at steady state, IP addresses aren't really changing. It's only really when we're doing deployments or like scaling our applications up and down that we need this mapping, right? So we can degrade in a way where we can serve stale results. And this is actually like a reasonable assumption to make because if you have like good observability, communication, and tooling in your organization, you can avoid having deployments happen when the core dependency is down. And so we actually came up with a plan. This is, we wrote this plan in a Google Doc and we actually shared it with the team beforehand. And we wanted to be very sort of like exact in the way that we described the game day that we are going to execute, right? So like all of our plans that we write start off with the prerequisites for what, like the conditions that need to exist before you actually start your game day. And I think almost always, if not always, it says the system is healthy, right? There's no point running this experiment if your stuff's already on fire. You're not going to get any useful information. You're going to be like, oh, well, it was broken before and now it's even more broken. That's not useful, right? So you always want your system to be healthy before you start. Then our plans always have an action that says what you're going to do to start the game day. So in our case, we're going to terminate all the database nodes. And then the plans also have an observability section. So this is where we say how we know that the action that we performed actually induced the failure that we expect, or some sort of failure, right? In our case, like we had a monitor that monitored whether we had database nodes, and we knew that as soon as we ran that action, we expected that monitor to go off. If that monitor doesn't fire, then like there's no point continuing with the experiment because we're already off the rails and we don't know if we even induced the failure that we expected, which happens a lot, honestly. And then finally, our plans also have like a cleanup step. So that's like what the action that you need to do in order to, or it's the inverse of the action that you're running, right? How do you like stop this experiment? And we all usually for the cleanup steps, like we have a specific command that anyone on the team who's following along with the game day can run, so that if like, even if someone's in the bathroom or like away from their desk, if we need to abort this thing, we can just run the cleanup command and clean everything up. But then the most interesting part of the game day is actually, so our expectations. If we go to the next slide here, we can see what they are. So these are actually like the expectations that we wrote down for this game day itself. It's very important to be sort of exact in before you actually run the experiment, you want to make sure that you have expectations that are very clear so that you can validate them during the experiment. So we actually like completely wrote these out before we actually ran it and had discussions about how we expected our systems to fail, right? So the basic idea is like, well, the database is down, no updates happen in the database, but the DNS server needs to stay up and serve cached results. And we should have monitors that like ping people on the team and let them know that things are broken so that they can go fix it. And our client should see no change in service. This is actually like a pretty interesting thing to explicitly state, even though you're saying like nothing should change and no one should notice. Like that's like an important, it's important to be explicit about things that you expect to not happen as well in these plans. And then, yeah, so when the database comes back, we expect everything to go back to normal without humans needing to do anything. We expect our monitors to automatically resolve themselves. This is an important one too, because if you don't have that stage and your monitors don't automatically resolve, you can get into situations where your operators miss pages and then go and start trying to fix systems that are actually working properly and can cause more problems there, especially if they're getting woken up at like 3 a.m. Yeah, so these were the expectations for the system. And then we ran the experiment and we validated that we actually met these expectations. But it turns out that we didn't actually at all. We had a bug in our error handling that caused the DNS server to crash when the database went down. So kind of a lot of the expectations here are marked as like a failure, but they're actually just sort of like irrelevant if the database server goes down, or if the DNS server goes down. But this was actually like a really interesting result that gave us a lot of information. So we took that and we created a follow-up task to fix that crash, and we ran the experiment again. And the second time that we ran it, everything worked correctly. But yeah, so that was like a failure that if we didn't run the game day, we would have it would have been like months down the line that we caught that, probably at 3 a.m. at the worst possible time, on Christmas or some day that no one wants to fix it. But like we were able to sort of fast track that. And this gave us the confidence that we needed to start adopting users for our system, and like also demonstrated to people who were thinking of depending on it that we had done actual testing and that like they should trust us when we say that it's going to work.
Cool. Yeah, seeing real life examples is great to get an idea what's this all about. And Mike, you're in the team who ran the large scale game days. Can you drive us through it?
Yeah. So if we stay in the theme of DNS, and we take like a view at, let's say, a cluster with a container scheduler, if you run Kubernetes or another product, this probably looks very familiar in that you have some service like Core DNS, which is a pluggable DNS server, has a lot of great features for forwarding in multiple domains. And then you have multiple resolvers. You might have a cloud resolver like Route 53. You might have some other ones like Elijah was describing. We have internal resolvers as well. So we're going to plan a game day, a DNS game day. And just like Elijah described, we're going to build a plan. And really importantly, we need to build our like assumptions, expectations, and risks. So in this case, we were looking at some outages or delays to different resolvers. And specifically, we're going to target the entire availability zone. So there's no opt-out here. If you are deployed, you are getting affected. We expected, overall, a small disruption of services. We knew we should have caches. Those caches might start to churn as data starts expiring. And that's going to lead to timeouts and retransmits. That's waves of traffic that are going to keep coming as retries. And redeployments, because as services start dropping out from their health checks, they'll get shuffled around. So the plan over a couple of game days was to ramp these outages progressively through a few different percentages, all the way up to a full outage for that availability zone. And 50% went great, 75% went great. We got to 98%, and this is where reality starts to set in. And you might call this like a rapid unplanned disassembly. So essentially, we had a couple of issues with our controller. This is a very old version of the controller that left these disruptions in place and wouldn't allow us to clean up automatically. So there's a lot of pain and suffering, but after that, we don't give up. We learn from that, and that includes ourselves. That includes our processes and everything like that. So some of the expected things like, our DNS and our service-to-service traffic, some control plane and data plane disruptions, that was all pretty expected. But we start to get into some of these more unexpected challenges. And what we learned was to be really over-prepared. We didn't have a backup safety hatch to release all of this disruption. And while we had inspected our disruption carefully, we hadn't validated the effects. So we had leaked some pods in places we didn't want them to go. And so that elevated the time to clean up. We also started looking deeper within like our processes. When things went wrong, turns out we didn't do a really great job of communicating during the cleanup of an incident. A couple of clusters had some lasting effects. And even observability, we were inundated with so much observability, we couldn't even react to everything that was happening. It was difficult to even like tell that, like I said, we had leaked some pods. So we've fixed these things. Like I said, we use our chaos engineering team's chaos controller that's open source, and you'll never see that architecture. You'll only ever see the changes, that we've learned from since then. And we've gone on to do full scale outages, delays of TCP traffic, of DNS traffic. Like partial outages are much weirder than full outages. And so some of the things we've learned, so some of the biggest lessons, when you want to start doing this at your organization, the number one thing is safety first. Take time to prepare. Elijah mentioned like it might take weeks or a month or more to plan for the game day. We have safety checklists. We take that from all kinds of industries. Surgeons do this, pilots do this. We have deputized coordinators with full scale authority. If anybody says stop, we stop. It's not a question of like, we want to, continue on. We even do iterative testing. We put the dry runs, when we do dry runs, we put them into place just for a minute or a few minutes before the game day. We want to see the dip and make sure that all of our safety indicators are operating as we expect. And we have a lot of backup plans. We don't just have one way to clean up. We have 2 or 3 ways to clean up. You don't want to be reflexively building a script right there, trying to clean up. You want to already have that as a please hit the next cleanup button. We need to, stop this experiment. And so how do we go through this? A lot of this, it's all collaborative research. We have platform owners, we have other product support teams, even us on Core Resilience, we have a chaos engineering team that helps us build these disruptions. We go work with the platform owners, product owners, service owners, and we keep track of each one of those people. We want them to then participate in the game day. If you've given us this amazing nugget of information and it helped us kind of guide this game day, we want you to be there. We want your systems to participate. that's kind of why we came to you as an expert. Along with that, it's communication. And really importantly, it's awareness. So go to every meeting, advertise everywhere you can, reach out to individuals. Hey, your team hasn't participated. Is there somebody you can nominate, or you've been nominated, please come. And we always hold a kickoff meeting. We get everybody together. We build a nice slide deck of all of our plans, our assumptions, our risks and expectations, and just bring everyone together and have a discussion. It's amazing, like, as how distributed as we are, just a 30-minute talk can really solidify people's earnest interest in doing this. And to that point, really set a dedicated schedule as early as possible. Decide what day your game day is going to be, and then work back. Have dry runs planned well in advance. And we even template all of our communication so that, you 24 hours in advance of a dry run, and immediately after, you need to warn the organization, say thank you. If you see anything, let us know. We have all that templated. So nobody has to be trying to craft a message to several hundred people. There's a lot of anxiety that comes with that. And anybody can step in. If somebody has to go to an appointment or is on vacation, there's no question of what we're doing. It's dated, it's timestamped and everything, and we send that out. I mentioned dry runs. So dry runs are super important. Most importantly, warn the organization before you do them, because the idea of a dry run is you're doing a small scale iterative development, sort of staging the game day up to your production release of the game day type of thing. It helps us reduce our assumptions and turn those assumptions into expectations. And to be really respectful of people's time, you're gathering a lot of people for these events. So in our first dry runs, it's usually just core resilience teams validating the disruptions, doing things like the chaos controller allows you to actually put pods into place without disruptions. So making sure we don't leak pods to places we don't want them to be. And then once we know we're solid, we know this is kind of going to do something, we bring the rest of the org in and say, we want to make sure that your observability that you've told us about is good, and it's going to tell us that we're in the safe or unsafe territory. And then kind of finally on the day of the game day, what we found is you really need participants to be engaged. So make sure that they really understand what you want them to do. An agenda, explicit directions, and expectations. Sometimes you want them to jump in. We want you to try and remediate. Sometimes you sit back, give us 10 or 15 minutes. We want to kind of learn and observe. Then we'll kind of release everybody, go do your fixes, run your runbook, stuff like that. A lot of safety checks. We have shutdown indicators. So they're these key metrics that if any one of these goes over a certain level, we stop right there. Just stop. That's, nobody has to debate it. We're over. We're into a chaotic space. We have to stop. And we really try to have fun. So music playlists, themes. Sometimes it's quotes from industry or we've had quotes from like our leadership. What's the smallest change that can break the world? Like that was a theme of a game day. We have leaderboards, so like people can win trophies for being in certain coordinator or organizer positions, and teams can say like, oh, we've done 12 of these, and kind of give bragging rights. Just some fun things to keep it light and engaging.
Cool, thanks. Thanks a lot to both of you for sharing the knowledge. I learned a lot while preparing this. I hope everyone here learned. We are going to go to the Q&A, so we have 15 minutes for the Q&A. Before we do that, if you think the problems are interesting, we're hiring, so you can go to our careers page. We are hiring in the SRE teams and also the rest of the engineering teams, so join us. And I'm going to start with the questions that we have from the audience. Again, if you want to ask any questions, you have a Q&A button in this Zoom webinar. I'm seeing a question as well happening on the chat. I'll address that as well, but if you can use the Q&A button, better. So the first question that we got during the session was about tooling. James was asking, are there any specific tools or software that we can help creating those disruptions? And Mike, you mentioned throughout the session a couple of times the chaos controller. Can you tell us a little bit more?
Yeah, that was actually, if you want to go back into some Datadog on history, there's a great video about the chaos controller. So We have a chaos engineering team, and they've built a Kubernetes controller that helps us put disruption pods into place through a really, really simple YAML definition, the pretty typical resource definition file. And if you're on different systems, there's like TC is a good tool. There's IP tables cause disruptions or block ports if you want to. You can set dead routes for Ethernet devices using like just route commands. And simple things like, just blocking a port. Like if you want to do a DNS style game day, block port 53. If you use a cluster orchestrator, intentionally down those pods, just take your DNS away and see what happens. Have a plan, but there's a lot of ways that, we can do these kind of simple things that don't require like a lot of custom tooling. For us, especially on the large scale side, the controller is kind of the only way we would be able to, we're, hundreds or thousands when you get to that scale. The simple manifest is really the way to go.
Cool. Yeah, I get pretty far with IP tables and kill-9. Those are really good tools. I've also used NS1 has a utility called Flamethrower, which is a DNS load testing application. And we used that pretty heavily when we were developing our DNS server in order to make sure that we could handle the load that we anticipated. And if you're doing DNS stuff, I think it's a great tool.
Cool. So the second question, although Chris asked a question and thought that was answered, but I think we can dive a little bit more into it. So they were asking, have you ever had game days that have spiraled out of control, for example, resulting in negative customer impact? And I think that also brings up the question of doing these things in production, doing them in staging.
Yeah, so for large scale, we haven't done a production large scale game day yet. That is the end goal for us. We have definitely torn staging clusters apart. We have caused, well, in different ways, we've had several hour cleanup type of things where, the sort of chaos got away from us and it took us a while to identify potential effects. There's a lot of token renewal and things like that if you block, you won't know for quite a long time. So yeah, we've definitely broken clusters. We've definitely broken services. And that's where a lot of the learning comes from is on running the game days is, okay, how do we avoid having to do that in the future?
Yeah, on our end of things, we've definitely made mistakes in the past where things cause bigger disruptions than we anticipate. But yeah, like Mike said, that's a really important part of the learning process. So far, still, we do normally run these on staging environments. Occasionally, we will run them in production environments. A thing that we joke about too is that incidents or outages are really just kind of like unplanned game days. And those are really good opportunities to actually figure out how your systems behave under adverse conditions, even if you did not cause them to happen. Never let a good crisis go to waste. And you can always learn something, when you do that. And like Mike said, we are aiming to run these on production systems soon.
Good. So we don't have any more questions from the audience, so we still have time. So if you have more questions, feel free to drop them there. I have some other questions that I had planned. So how often do you think this game day should be run?
Do you want to go first, Elijah? I think our answers are very different.
Yeah, on smaller scale systems, I think we really try to do them after we make significant changes to parts of our application that handle sad paths. So if we change the way we manage database connections, for instance, we probably want to run an experiment after that to make sure that we haven't regressed and that we still handle those failure modes as expected. We also do try to sort of do game days regularly, even when we think that things haven't broken, because like, if you could predict that a change was going to break something, then you probably would have fixed the thing that it was going to break and not known it at all. And sometimes things can sneak up on you or your platform can change. So on our end, we try to do game days maybe once every like 4 to 6 months on our systems, just to make sure.
Yeah, I think overall, the answer is regularly, frequently. And it's, I think for, big ones, it's going to depend on what big kind of means to your organization. We run them at least quarterly, but we also have teams reach out. We mentioned that we don't do them in production. We do sometimes. We'll have teams that reach out and say, we need to do this major event. We want core resilience to help us organize and plan. So that can kind of affect that. It also depends on what cycle you're on. So if chip manufacturers, they do like a TikTok type of thing. So if it's your first time running this particular scenario, you'll probably need a lot more lead time and a lot more testing. If now you're just iteratively going from like, the 50% to 75%, you probably have most of that research done and you can jump onto the next one kind of as soon as your organization can support, which is another kind of facet. Like, when you are involving dozens or hundreds of people, that's a lot of organizational like engineering time that you're asking for. So it's really important to be like really respectful and not, because like platform teams, especially platform teams are going to be at every game day. So you're stressing those teams a lot. So we try to give them enough bounce times. Like, we know you have work to do. We're adding more remediation items. So we do them at least quarterly, but they definitely happen more frequently on average than that.
So, and following on that also, Mike, you were talking about all the planning that involves running one of these. On average, how long can it take to plan one of these events?
Depending on, if it's your first kind of like foray into whatever scenario you're running, 6 to 8 weeks to get to a game day. And the majority of that is research. You really, a week to 2 weeks of dry runs should be pretty good, depending on, how often. If you can run them every day, you might only need a week. But yeah, probably the majority of that time should be spent in research and design, confirming your assumptions and expectations, developing safety and rollback plans, stuff like that. And that's why it can kind of seem like you get to the event and it's like, oh, poof, it's just done, because you spend so much, but you owe the organization that safety if you're going to ask them to do this.
So for people who are watching and may not be running game days at their organizations yet, and they're thinking, okay, this is going to be difficult to convince my managers to do this, what would you suggest? How do you convince upper management to this is a good thing?
It's sort of a paradox, but I think by breaking things, you actually make them better. I would really stress, that all the failures that you're going to induce are going to happen at some point, and you would rather have those happen when you're watching.
Yeah, I think it's really important to start in the small scale and just be exercising your services. So I don't think it's necessarily something that like large scale probably needs a lot of organizational and leadership support. But I don't think it would be necessarily that easy to start a large scale program at any size company if you aren't already doing some sort of exercised failures. I think for us, it was kind of a decision that like, yeah, learning from incidents is great, but that's not a good feedback loop for us. We need to be in front of that because of the responsibility we have to our customers. And I think that's that's kind of the emphasis. The large is really just about trying to induce the type of failures that the world is going to throw at you. And how, you kind of need the organization to react to those things, just like you would during whatever your company's version of a SEV1 or a full outage would be.
Yeah, and you can really start small, right? If people are afraid of sort of like completely breaking a system, you can do things that you don't expect to cause as much problems. Like maybe if you have a few web servers running, you can take down one of them and sort of demonstrate like, hey, we thought this wouldn't make a difference, and we've proven that this is the case. You can kind of like plan them in ways where you don't actually induce failure that's visible to your customers or users.
And a good place I think to start is where you're already training people. So on-call training, like simulating a large-scale game day might be enough. You can pace people through run books and situations. You can kind of organize stress and stuff like that. So you don't necessarily need to, like we said, we organize all kinds of outages, communication outages, people are gone, things like that. So those are things you can throw at the organization without saying we're going to literally break something. You know, we're breaking the organization's communication style, or we're breaking the dependency on people, not so much like, hey, we're going to go take production down and see what happens.
Sounds good. And also, I would add that this session, that it's been super informative. Thanks again, Mike and Elijah. It's going to be recorded, so you can always pass the recording to your managers. Okay, so it doesn't seem that we have any more questions, and we are about time. So thanks again, Mike and Elijah, for joining. This was great session. Thanks again, and thanks everyone for joining.